Hi, in this video we're going to continue talking about loans, and in particular you can see we're going to talk about some loan balances. Made a comment last video that it's important to be able to calculate these loan balances. A lot of times that's, if not the final step, an intermediate step in each problem. So we're going to spend quite a bit of time talking about how to calculate these loan balances. Okay, so here's my timeline. This is what the general timeline looks like. The cap B sub K is going to be the balance just after that kth payment. Again, cap L is going to be the loan amount. There's going to be two ways to calculate these balances, and I want you to kind of see the big picture. I think this exam is much easier to study for this exam if you'll just learn the big picture and the general ideas of things instead of trying to just memorize formulas. And so that's what I'm going to try to convince you of here and try to show you. So there's going to be two ways to calculate these loan balances. Both ways, after you see them, I think you'll develop some intuition and it'll be intuitive to you. So one way to calculate a loan balance is what's called a retrospective method. Retrospective means we're looking backwards in time. So at time K, we want the balance at time K, and we want to look at, well, what has happened up to time K, up to and including time K. Well, the payments after time K, those haven't happened yet. So retrospectively, I'm not even thinking about the payments after time K, so I'm just going to delete those off of the slide. So this is what the picture looks like retrospectively up to time K. And then retrospectively, the balance at time K we can think of as just the accumulated value of the loan amount. Take the accumulated value of the loan amount. That's how much you would owe at time K had you not made any payments at all. But the fact of the matter is you have made some payments. You've made this payment at time 1, this cap C sub 1, at time 2, a cap C sub 2, and so forth. So you need to subtract off from the accumulated value of the loan amount what the accumulated value of the payments that you've already made, those past payments. And so that's it. That's what the big picture is for the calculation of the balance of the loan at time K. Again, try to develop some intuition on this. It should make some sense to you. You accumulate what the loan amount is up to time K. That's how much you would owe if you didn't make any payments. But then subtract off the accumulated value of the payments that you've made. Not a whole lot we could do with this expression except for the fact that we could accumulate the loan amount. So the loan amount I'm accumulating from time 0 to time K, so I multiply by that loan amount times a 1 plus I to the K. So that's the accumulated value of the loan amount. There's not much I can do with the accumulated value of the past payments because I haven't made any assumptions on what the past payments are. What we're going to find out later on is if we assume the payments are all level, if they're all the same amount, then I can come up with some formulas for this retrospective method of calculating the loan balance. I don't really want to show you that right now though, because again, I want you to see the big picture and just kind of think about the big picture. So that's it. That's the retrospective calculation for the loan balance at time K. There's another way to think about loan balances. So let me put in all of the payments again. And the other way is what's called a prospective calculation. So prospectively means we're going to look forward in time. We're not, we're looking just forward in time, starting at time K. So looking, forward in time, what's left to do? Well, all the payments up to and including at time K have already been made because remember, cap B sub K is the balance just after that kth payment. So the payment at time K, that cap C sub K, is actually a past payment. So prospectively, I wouldn't even, that's not even part of the picture prospectively. So prospectively, those are the payments that are remaining to be made. And this, again, very easy. Once you see it, try to, just kind of think through it logically. The balance that you owe at time K prospectively is just going to be the present value of all of those remaining payments. Present value of payments, the remaining payments is the balance at time K. Okay, so let me put all the payments back in. This is what the picture generally looks like. Now, we can actually use this prospective method to kind of relate the payments to the loan amount. at time 0, that's the balance at time 0 is the loan amount, and it's just going to be the present value of the remaining payments. Well, at time 0, you have all the payments that are left to be paid. And so the loan amount, anytime you have a loan problem, the loan amount is just the present value of all the payments. Okay, so last time we talked about calculating values for like the amount of interest in a certain payment and the amount of principal in a certain payment, and I'm going to need to kind of revisit those in order to get to the next topic that I want to talk about. So that was this cap I sub k and cap p sub k was the notation that we were using. Cap I sub k being the amount of interest paid in the kth period. Sometimes it's called the kth installment, but I'm just going to say the kth period. And remember, or let me just mention, we get the amount of interest paid. So this is a basic fact that you need to know and to think about, develop some intuition on. How much interest do you owe at time k? Well, you back up the balance to time k minus 1, and you just multiply that by the interest rate over that whatever the interest rate is for the period. So the periodic effective interest rate I. So the amount of interest that you're going to pay at time 10, I look at the balance at time 9, and I multiply that times whatever that periodic effective interest rate is. That goes back to Module 1 stuff. We were doing this sort of stuff in Module 1. The amount of interest at time 25, I look at the balance at time 24, and then I multiply that by the periodic effective interest rate. Okay, so that's how we're going to calculate the amount of interest at a certain time period at time k. And then the amount of principal being repaid with the kth payment, that cap p sub k was the value that we used for that to represent that amount. And of course we know we know the relationship between the total amount of the payment and each of these symbols. So I take the total amount of the payment, that's cap c sub k, and I subtract off the amount of interest that I'm owing or that I pay in the kth period or at time k. And you see that there's the way that we calculate that is written above, and that difference is going to be the amount of principal that's going to be repaid with the kth payment. And so if I'm asked to calculate the amount of principal repaid in the kth payment, I do that by first calculating the amount of interest. Generally, I first calculate the amount of interest that I pay, and then subtract that amount of interest that I'm paying in that payment from the total amount of the payment. Now, think about the words. It's the amount of principal that you're repaying. So if you take the amount of principal that you're repaying in the first payment, you add to that the amount of principal that you're repaying in the second payment. You do that for each of the payments. Add all of that up, you're just going to get the loan amount. In other words, the relationship here is that the loan amount is going to be equal to the sum of all these p sub k's, from k going from 1 to n. Okay, the last thing I want to get to in this particular video is balances at neighboring time periods. So I'm going to look at a time period k, and then time period k minus 1, and then move forward to time to time k. And I want to kind of relate. I want to know how to relate those two balances at those different neighboring time periods. Well, what accounts for the difference in those two values generally is the amount of the payment at time k. That's the only thing that's going to account for the difference between those two balances. And let me remind you, again, this is just kind of think through it logically, that the balance just after the payment at time k would be the balance just before the payment at time k minus the amount of that payment. And the amount of that payment I'm denoting by cap c sub k. And then remember from last video, we talked about how you could get the balance before the payment at time k by taking the balance just after the payment at time k minus 1 and accumulate that for a period by multiplying by 1 plus I. And so what I'm about to do is take the expression in red that's in the second equation, take what's in red in the second equation, and substitute that in for what I have in red in the first equation. And then you can see that I can relate the balances at the neighboring time periods this way. the balance at time k would be I take the balance at time k minus 1. And when I say at time k, I mean just after the payment at time k. That's what that symbol's representing. So I take the balance just after that payment at time k minus 1, accumulate it, and then subtract off the payment amount. Okay. Now what I'm about to do is go through another, I want to show you another way to calculate, another way to relate these balances. Just bear with me. Let's kind of go through this. I think that seeing the derivation is useful. And so what I want to do is this, in this last expression that you see there, distribute the cap b sub k minus 1 across that parentheses, and you get a cap b sub k minus 1 plus an I times a cap b sub k minus 1, and then minus the cap c sub k. And remember, the cap c sub k is the amount of the payment, and we could separate that into the two pieces: the amount of interest that's being paid with that payment and the amount of principal that's being repaid in that payment. And the amount of interest that's being paid in that payment is you look at the balance at time k minus 1 and you multiply that times I, and notice that I have that highlighted in blue because that shows up in that last expression. So what's in blue, in the last expression, I'm just going to replace with the cap I sub k value. And so let me clean up the picture a little bit. The other thing that I want to recognize is that the total amount of the payment is the sum of the cap I and the cap P values. And so I'm going to substitute that in the very last expression, the last term in that last expression, the very last thing you see there, the cap C sub k. I'm going to substitute in cap I plus cap P sub k's for that one. And then the cap I's, if you look at the expression that I have, then the cap I's are going to add out. And so what I end up with is the last expression just becomes the cap b sub k minus 1, and then I distribute that minus sign. It's minus cap p sub k. Okay, and so this gives me a second way to relate the balances at neighboring time periods, namely that last equation that I have, the balance at time k. I could take the balance at time k minus 1 and just subtract off the amount of principal that I'm repaying at time k. So these are the two formulas that relate the balances at neighboring time periods. And again, they're not hard formulas if you just kind of think through this logically, think through what's going on. The first equation in the box there, the first equation, the first formula is saying you get the balance at time k by taking the balance at the time period before that, accumulate it with interest, and then subtract off the entire amount of the payment. And then what's in the second box is I could calculate the balance at time k by taking the balance at time k minus 1. Don't accumulate it or anything, but you're not subtracting off the whole payment. You're only subtracting off the amount of principal that's being repaid in the payment at time k. Okay, so those are your two formulas, and depending on what information is given to you, you'll want to use one or the other. So you want to get used to using both of these formulas. Because, again, sometimes they'll give you limited information. You have to use one formula versus the other. Okay, well, I will see you in the next video.